Hey there, and welcome to the Coding Ikigai. I'm Harsh, a software engineer at Oracle, and I am on a mission to help you find your niche, your Ikigai in the world of programming. You are about to dive into the Core Java Programming series, a completely free, in depth guide designed to know everything there is about the Java programming language and to get you industry ready. So, let's get started. This is episode 2. What can you put inside main? A guide to elementary programming in Java. And you are watching a series of such episodes to gain a deeper understanding of the Java programming language. I have broken down the episode into multiple chapters, so if you're already familiar with the topic, go ahead and jump to the next one.
To start, press any key. Where's the any key? I see ESC, Catarl, and Pickup. There doesn't seem to be any key. Whew. All this computer hacking is making me thirsty. I think I'll order a tab. Oh, no time for that now. The computer's starting.
Communicating with a computer involves speaking the language which the computer understands. In our last episode, we saw that the computer only understands instructions which are written in machine code or binary code, whose encoding or format should be in accordance with the instruction set architecture or ISA of the CPU or processor chip that you are using. Communicating in machine language requires using only the characters 0 and 1. So you would have to write your instructions to the computer entirely with these binary digits. And oh boy, that's very difficult. Trust me. However, Java bridges that gap and simplifies that part for you. How? Listen to this. Java says that if you give me a set of instructions following my grammar, my syntax, and my rules, then my compiler and JVM will make sure that your code is translated into the correct binary encoded instructions, whether you are running on Intel, Apple Silicon, or AMD. It does not matter. So that's the promise which Java makes to you. But how do you chat with a computer using the correct grammar or syntax of Java language? Is it exactly the same as chatting with your girlfriend over coffee? No, because for once, a computer will understand you, but your girlfriend? Never. Computers in daily life are used for solving complex and tiresome problems. But is it possible to hand over a problem to a computer written in plain English on a piece of paper and expect it to solve it? So let's say someone asks the computer, can you find the area of a circle with radius r? Sure, it's a simple task for you. Pi r square. It's like a walk in the park. But to a computer, that question means absolutely nothing. The only way a computer can understand is if you give it instructions using the grammar of Java or any other high level programming language and then execute it. So let's dive into the syntax of Java programming language and see how to make it speak your language. There is a close analogy between learning English language and learning Java language. The classical method of learning English is to first learn the alphabets used in the language, then learn to combine these alphabets to form words, which in turn are combined to form sentences, and sentences are combined to form paragraphs. Learning Java is similar and easier. Instead of straightaway learning how to write programs, we must first know what alphabets, numbers, and special symbols are used in Java. Then using them, how to construct constants, variables, and keywords. And finally, how they are combined to form an instruction or a statement. A group of instructions would be combined later on to form a program. Here's an illustration to understand the analogy. A typical Java program is fundamentally composed of a variety of characters, including English alphabets, digits, square brackets, semicolons, and special symbols. These characters, when combined, form words such as keywords like public, class, static, final, double, variables like pi, radius, and area, and constants like 3.14 and 20.4. When these words are assembled, they create instructions or statements such as double radius is equal to 20.4, which directs the Java program to store the value 20.4 in a variable named radius of type double. This type of statement is known as an assignment statement or expression statement. And finally, A collection of such statements results in the formation of a complete Java program. So let me take you to those good old kindergarten days and teach you the alphabets of Java programming language. Characters are the smallest units of fundamental elements of any language, and together they are referred as a character set. These characters are further used to give more shape and meaning to the language. In English language, we have 26 such characters, that is from A to Z. A computer stores everything in its memory in the form of bits, which are basically binary numbers. To handle letters and other characters, computers assign a number to each character. Mapping a character to a number is called character encoding. The set of such encoding together form an encoding scheme. And yes, there exist hundreds of such encoding schemes out there. For instance, imagine that the letter capital H could map to number 163, capital E to 51, capital L to 187, and capital O to 255. And voila! That is how a computer can store a full word like hello in its memory, not as letters, but as a sequence of numbers. On a side note, Java is case sensitive, which means that it treats capital and small letters as two distinct characters, unlike English. The early character encodings were limited and could not contain enough characters to cover all the world's languages. Even for a single language like English, no single encoding was adequate for all the letters, punctuation, and technical symbols in common use. Early character encodings also conflicted with one another. That is, two encodings could use the same number for two different characters or use different numbers for the same character. Any given computer, especially servers, would need to support many different kinds of encodings in this case. When data is being passed through different computers or between different encodings, the risk of data corruption exists in the transformation process. Hence, it's essential to establish a universal standard for character encoding, a common language that all the computers around the world can agree upon and use them consistently. Unicode changed all of that. The Unicode Standard is the universal character encoding scheme designed to support the worldwide interchange, processing, and display of the written text of various languages and technical disciplines of the modern world. In addition, the Unicode Standard also supports classical and historical text of many written languages. For instance, here is how the Unicode for Egyptian hieroglyph look like. Pretty cool, right? You can find the link for official Unicode standard specification document in the description down below to check what all languages does Unicode support. You will be pretty surprised by the vastness of it. The Unicode standard provides a unique number for every character, no matter what platform, device, application, or language you are using. It has been adopted by all modern software providers and now allows data to be transported through many different platforms, devices, and applications without corruption. Support of the Unicode laid the foundation for the representation of different languages and symbols like Hindi, Telugu, Tamil, French, Italian, etc. in all major operating systems, search engines, browsers, laptops, and smartphones, including the internet and World Wide Web. Unicode is an implementation of ISO standard 10646, which is an international standard for character encoding developed by the International Organization for Standardization, that is ISO. You might have heard of it. A standard is an established set of guidelines or criteria that is widely accepted and are developed to ensure consistency, safety, and interoperability across various systems. I will attach the link for this ISO 10646 in the description down below. You can go and check that. The Unicode was originally designed as a 16-bit character encoding. It was known as UTF-16, where UTF stands for Unicode Transformation Format. For example, the Latin letter capital A was denoted by the hexadecimal code 0x0041. This flowchart depicts the breakdown of the Hindi word purti into its various vowels, consonants, and matras, also known as diacritics or glyphs, by the text renderer of Unicode and stored in the format of different 16-bit Unicode encodings. Sweet, right? However, it turned out that the 65,536 characters, that is 2 power 16, possible in a 16-bit encoding, is not sufficient to represent all the characters in the world. Because damn, there are more than 7,000 languages and more than a billion dialects in the world. I mean, why? Why was it needed? The Unicode standard, therefore, was extended to 32-bit encodings, or UTF-32, to allow up to 1 million characters. Those characters that go beyond the original 16-bit limit are called supplementary characters. And now, for the moment you have all been waiting for, after so much ranting, Java supports Unicode UTF-16 character set and represents text in sequences of these 16-bit code units. Yes, that's the big reveal, and that was the character set of Java programming language. If you have been programming for a while, you must have heard of the term ASCII. ASCII, or American Standard Code for Information Interchange, was the first major character encoding standard for data processing. It was developed in the early 1960s and was the most common character encoding format for text data in computers and on the internet. ASCII is a 7-bit encoding scheme used for representing all the essential characters like uppercase and lowercase English letters, digits and punctuation marks, and control characters. It consists of a total of 128 characters only, and it is a subset of the Unicode, as the first 128 characters in the Unicode maps to these ASCII characters. And that's all we need to know about the alphabets of Java programming language. Voila! Remember this Java code? In this program, double and string are Java data types. Let's investigate the data types in Java programming language. Memory, or RAM, as we know, is a limited resource, and in Java, it needs to be estimated upfront as to how much space you will be needing for your requirements. Data type is a property associated with a piece of data which tells two things. First is size, as to how much memory needs to be reserved for that data. This also sets a limit on the maximum value that can be stored in that memory location. For example, an 8-bit data type can store only up to 2 power 8, that is 256 numbers only. The second is type, as to what kind of data you can store inside that memory, like integers, floating point numbers, characters, or references to other objects. All of this helps Java limit the type of operations that you can perform on that data. For example, division is applicable only to integers and floating point numbers, but not to strings and characters. These characteristics make Java a statically typed and strongly typed language. Strong static typing allows errors to be detected at compile time. Now let's explore the range of data types Java offers to its developers. In the Java programming language, data type are classified into two categories, that is primitive type and reference type. Since we haven't introduced the concept of OOPS, classes and objects, for the time being, we will skip the discussion on reference type for future episodes. Java provides a total of 8 primitive data types, which are further divided into two categories, that is numeric and non-numeric data type. The numeric category includes data type for storing integer values, namely byte, short, int, long, and char, as well as data types for storing floating point values such as float and double. On the other hand, for non-numeric data type, we have Boolean as the data type. Let's see each of these primitive types in detail. The data type with the smallest size in Java is byte. When you declare a variable of type byte, Java allocates 8 bits or 1 byte of signed memory. The term signed indicates that one of these bits is reserved for storing the sign of the number, that is positive, plus sign, or negative minus sign. Byte type can only store integer data inside it, and those integral values can lie only from minus 128 to 127. By default, a byte data type is initialized to 0. It is important to note that Java does not support byte type numbers as literals or constants in the program. A little bigger than byte is the short data type. When you declare a variable of type short, Java allocates 16 bits or 2 bytes of signed memory. It's pretty big, right? 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 Short type can only store integer data inside it, and those integral values can lie within the range as shown in the table. By default, a short data type is initialized to 0. It is important to note that Java does not support short type numbers as literals or constants in the program, just like the byte type numbers. Next in line, we have is int data type, which reserves 32 bits or 4 bytes of signed memory. Int type can only store integer data as well, and those integral values can lie within the range as shown in the table over here. By default, an int data type is also initialized to 0. It is important to note that any numerical literal or constant that you define directly in a program, such as minus 50, minus 2, 5, 29, or 46, they are all treated as int data type by default. So all properties of int data type applies to these numbers. Last we have is the extra large size, that is long data type, which allocates 64 bits or 8 bytes of signed memory. Long type can only store integer data, and those integral values can lie within the range as shown in the table over here. Is that enough for you? By default, a long data type is initialized to 0. To define a numerical literal or constant of long data type, you need to suffix the number with a capital L or a small l, such as minus 50L, minus 2L, 5L, 29L, or 46L. This way, Java will know to treat your numbers as long data type. Next, we have is float. Float is used to reserve 32 bits or 4 bytes of memory according to IEEE 754 standard. Again, this is the standard. I will link in the description down below. It is designed exclusively for storing floating point numbers, not integers. Its default value is 0.0, and to define a floating point literal of float data type, you must suffix the number with a capital F or small f. This way, Java will know to treat your numbers as a float data type. The largest data type in Java offering the highest precision is double. Double reserves 64 bits or 8 bytes of memory according to IEEE 754 standard. Just like float, it is used solely for storing floating point numbers, not integers, and has a default value of 0.0. By default, every floating point number that you declare in your program is treated as a double data type. To explicitly specify a number as double, you can suffix it with a capital D or small d. It is your wish. The non-numeric data type char, as its name suggests, is used for storing characters. It occupies 16 bits or 2 bytes of unsigned memory. Since a character is essentially a number, you can assign integer literals between 0 and 65,536 directly to a char variable, and Java will automatically convert the integer to its corresponding Unicode character. The char type can store all characters in the Unicode UTF-16 encoding. And the last primitive data type is Boolean. The Boolean data type represents a logical value that can be either true or false. While conceptually, it represents a single bit of information that is either 0 or 1, true or false. The size of the Boolean data type is 1 byte or 8 bits in Java. Only two values, true and false in lowercase, can be assigned to a Boolean variable. By default, a Boolean is initialized to false. We will cover reference type after the introduction of OOPS in Java. Congratulations! Now you can tell your boyfriend about different shapes and sizes which you saw today. In Java, of course. Remember this Java program? We will come across this multiple times in this episode, so don't worry. 20.4 and 3.14 are literals in this program. Let's understand the literals in Java programming language. A literal, also known as Java constant, is an entity that does not change throughout the course of the program. They represent fixed values that cannot be modified, like the integer value 4 or a string value apple. Java offers 6 different types of literals: integer literal, floating point literal, boolean literal, character literal, string literal, and null literal, some of which further have types inside them. Let's see each of them one by one. Integer literals are numbers that do not have a decimal point or an exponential part inside them. Basically, integers in mathematics. In Java, an integer literal can be expressed in 4 different formats. The most common format is decimal, which means to represent numbers using base 10. Then we have hexadecimal using base 16, octal using base 8, and binary using base 2. Any integer literal is by default of the integer data type. However, if we suffix it with capital L or a small l, then it becomes of long data type. For example, 26 and 3267 over here are of int data type and takes 32 bits of space in memory. However, if you suffix L to the same numbers, it becomes 26L and 3267L, then they become of long data type and take 64 bits in memory. A decimal integer literal consists of 10 digits, that is from 0 to 9. An octal integer literal comprises of 8 digits, that is from 0 to 7. And to represent them in Java, we need to prefix the octal number with a 0. For example, 045, 026, negative of 035, they all represent octal numbers in Java. A hexadecimal integer literal comprises of 16 digits, that is from 0 to 9 and A to F. And to represent them in Java, prefix the number with 0x. A binary integer literal comprises of 2 digits, that is 0 and 1, and to represent them in Java, prefix with 0b. To enhance readability of bigger and longer numbers, we can separate the digits using underscores as shown in this example. 901 underscore 306 underscore 445. Java compiler will ignore these underscores completely. So, in this example, 394 in decimal, 0b1011 in binary, 0x7ab in hexadecimal, and 0256 in octal. All of them are integer literals with int data type by default. Whereas, if we append the same numbers with capital L or a small l, then they become of long data type, as you can see over here. Floating point literals are used to represent and store real numbers. These literals can be expressed in 2 formats: decimal, base 10, or hexadecimal, base 16. There is no such binary or octal in the case of floating point literals. By default, a floating point literal is of the double data type. However, if it is suffixed with either a capital F or a lowercase f, it is treated as a float data type. For instance, 34.256 is a decimal floating point literal, and if it begins with a 0x, then it becomes a hexadecimal floating point literal. By default, all these literals are of double data type, taking 64 bits of memory. However, if you suffix the same literals with capital or lowercase f, then they just become a float data type, taking 32 bits of memory, as shown in this illustration. Isn't that just amazing? Underscores can be used as separators in the whole number, fractional, and exponent part. An exponent just represents a scientific notation. For example, 1.2345 E2 is equivalent to 1.2345 into 10 raised to power 2. A floating point literal consists of several parts. A whole number part, which can be either in decimal or hexadecimal format, followed by a decimal point. A fractional part, which can also be in either decimal or hexadecimal format. An optional exponent part, prefixed with capital E for decimal or P for hexadecimal, and an optional suffix to represent the data type of the literal. A character literal, as the name suggests, is of the char data type and represents Unicode UTF-16 characters. Character literals can be classified into two types, a single character or an escape sequence. Java uses a special notation to represent non-graphic characters such as space, return, backspace, and tab by prefixing a backslash to a particular character. These notations are known as escape sequences, and they are very special. Here's a list of escape sequences supported in Java. For instance, \b represents the action of backspace, \t represents the action of tab, and so on. These escape sequences are essentially alternate names for specific Unicode characters, and you can also use the Unicode representation to achieve the same result. There is no difference. Character literals can be specified in several ways, like using a direct character enclosed in single quotes like capital C, or by using their Unicode representation like \u 0061, or by using escape sequences for certain special characters like \n for new line and \t for tab. A Boolean literal is of data type Boolean and can take only two values, true and false, all in lowercase letters. And voila, that's all you needed to know about literals in Java. You're now an expert in that. Remember this Java program? Class names like compute area, string, and system. Method names like main and println. Variable names like radius, area, and args. All of them are identifiers. Let's understand what are identifiers in Java programming language. A person's name is important because it is literally a huge chunk of their identity. It is a way to distinguish you from other person in the society. For example, names like Ben Dover, Mike Hawk, Mike Litteris, and Phil McCracken each represent different individuals in society. Similarly, in programming, identifiers are names that distinguish various elements such as classes, methods, and variables from one another. All identifiers must obey the following rules. An identifier is a sequence of characters that consist only of letters, digits, underscores, and dollar signs. Only these four categories. An identifier must always start with a letter, an underscore, or a dollar sign. It can never start with a digit. So 123 hash is an invalid identifier. An identifier cannot be a reserved keyword. We will see the list of reserved keywords in a while. An identifier also cannot be true, false, or null because they represent reserved Boolean and null literals. And an identifier can be of any length you want. Now that we know the rules of naming identifiers, let's play a game. Who wants to be a millionaire? If you answer all 5 questions correctly, you will win $1 million. You can pause the video to get your answers ready. So let's begin. Is my variable a valid identifier? Yes, it follows the first rule. Is 4ART a valid identifier? No, it violates the second rule. Is A plus C a valid identifier? No, it violated the first rule. Is my dollar a valid identifier? Yes, it is a valid identifier. Is class a valid identifier? No, because it is a reserved keyword and it violates the third rule. Congratulations if you answered all 5 correctly. You can redeem your $1 million at Children Bank of India. Sorry, that was lame. Just like certain phone numbers are reserved for special purposes, such as 911 for emergencies in the US of A, or 100 for contacting the police in India, there are also specific names in programming that are reserved for certain purposes. These reserved words are known as keywords, and they have predefined meaning that define the structure, behavior, and flow of a program. The first set of keywords are reserved for data types, whose purpose we already know. Then some keywords are reserved for object-oriented programming concepts like class declaration, inheritance, etc. Some are reserved as access modifiers like public and private, and some are reserved for concurrency purposes like synchronized. Some are reserved for controlling the flow of the program like if, else, switch, break, etc. While the rest of them serve the purposes of exception handling like try, catch, throws, testing, package handling, and other miscellaneous purposes. We will understand each of these keywords as we come across them in future episodes. So stay tuned. A variable is a data container that stores different values during the execution of a Java program. Variables are used to represent data of a specific type. Each variable has an associated name and data type. To use a variable, it must be declared first. The syntax for declaring a variable is the data type, followed by the name of the variable and a semicolon. By default, a variable is initialized with the default value of its data type that we already discussed. However, if you wish to initialize it with a specific value of your choice, the syntax is the variable name followed by an equal sign and the value you want to assign to it. Let's understand with an example. Suppose you declare a variable with name my variable and attach an int data type to it. This will tell the JVM to reserve 32 bits or 4 bytes of memory and assign the name of this variable to that particular memory segment so that it is identifiable. That is the use of identifiers, right? JVM will also initialize this memory segment with the default value of 0. Let's say we now assign 29 to this integer variable. Then JVM will replace 0 with the integer literal 29 in the memory. Similarly, if you assign 321 to the variable in future, then 29 will be replaced by this integer literal 321. However, if you attempt to assign the values 432L or 5.02 to our integer variable, the Java compiler will throw an error indicating type incompatible. This is because 432L is a literal of the long type, which requires 64 bits of memory, and you cannot fit a large value inside a small cup. Additionally, 5.02 is of double data type, and the int data type can only store integers and not floating point numbers. These errors are detected at compile time. So that's the advantage of being a statically typed language which Java offers to us. Let's consider another example. Suppose we declare a variable named count with a data type of byte. Similar to the previous example, Java will allocate 8 bits or 1 byte of memory for this variable and initialize it with the default value of 0. Now let's assign 29 to our byte variable. As you might recall, that Java does not support byte literals, and we haven't even discussed that in the literal section, right? And by default, any integer literal is of the int data type, which is 32 bits. And I just told you, right, a few minutes back, that you cannot fit a large value inside a small cup. So how did it fit? Since 29 is within the range of byte data type, Java automatically converts this literal into byte type. However, if you assign or if you attempt to assign the value 130 to our byte variable, the Java compiler will throw an incompatible type error. Why? It could have fit in, right? Because the byte data type has a range of values from minus 128 to 127. And since 130 is out of that range, it is considered invalid. The value of a variable may change multiple times during the execution of a program, as we just saw. But a named constant represents permanent data that never changes. In Java, a constant is also known as a final variable. Named constants enforces a rule upon the compiler, ensuring that their value can never be changed in memory. The syntax for declaring a named constant is similar to that of declaring variables, with the key difference being the use of final keyword as a prefix to that statement. By convention, all letters in a named constant are written in uppercase. For example, final double pi, where p and I are in uppercase, is equal to 3.14159. It declares pi as a final variable and pi is the named constant. If you attempt to change its value, Java will generate a compile time error. Remember this Java program? Symbols like equals, multiply, and plus are all operators. Let's see what are operators in Java programming language. Operators are used to perform various operations on variables and values across different data types. They are special symbols designed to perform specific operation on one, two, or three operands. And eventually, they all return a result. Remember that. Let's look into the different types of operators in Java programming language. The first set of operators are arithmetic operators, which includes the standard mathematical operation. The plus operator is used for addition, so 10 plus 3 returns 13. The minus operator is used for subtraction, so 10 minus 3 returns 7. The star operator is used for multiplication, so 10 star 3 returns 30. The slash operator is used for division, so 10 slash 3 returns 3.33333 and so on. The modulo operator is used for finding remainder, so 10 modulo 3 returns 1 as remainder. As you can see, all of these operators are binary operators, that is, they take two operands. The next set of operators are relational operators. These are also binary operators, that is, they take two operands, but they return a Boolean value. Java provides 6 relational operators. Their names are self-explanatory. Consider two numbers, 10 and 3, and ask yourself a question. Is 10 equal to 3? No, so it returns false. Is 10 not equal to 3? Yes, so it returns true. Is 10 less than 3? No, so it returns false. Is 10 greater than 3? Yes, so it returns true. Is 10 less than or equal to 3? No, so it returns false. And is 10 greater than or equal to 3? Yes, so it returns true. The next set of operators are logical operators. These are also binary operators, but they work only on Boolean operands, that is true or false, and returns a Boolean value. Java provides 4 logical operators. The first one is AND, which returns true if and only if both the operands are true. Next is OR, which returns true if at least one of the operands is true. Following is exclusive OR operator, which returns true if and only if the operands have different Boolean values from each other. So if one is true, then the other operand should be false for the overall result to be true. Lastly, the NOT operator is used for negation or flipping the Boolean values. So true becomes false and false becomes true. Bitwise operators are similar to logical operators that we just discussed, but they operate on individual bits of an operand. The supported data types for bitwise operations are byte, short, int, long, and char. Java offers 4 bitwise operators: bitwise AND, bitwise OR, bitwise exclusive OR, and one's complement or the negation. Let's see all of them in action. The integers 57 and 99 are first converted into their corresponding binary format, after which the computer performs operation on each individual bit of the binary number, as you can see over here, starting from the rightmost bit and moving to the left. The rules for AND, OR, exclusive OR, and negation remain similar to those of the logical operators. Here 0 stands for false and 1 stands for true. Finally, the resulting binary number is again converted back into an integer and then returned as the result. The next set of operators are shift operators. Java offers 3 shift operators: left shift, right shift with sign, and right shift with 0 extension. These are binary operators and work on operands with data types byte, short, int, long, and char. Let's see them in action. The left shift operator moves all the bits of the binary number to the left by the number of positions specified by the second operand. The bits shown in red represents the original bits of the number, and as they shift left, the leftmost bit of the binary number is completely discarded. It can never be recovered. The vacant positions on the right that are created as a result of this shifted are filled with zeros represented in black color. Left shift effectively multiplies the number by 2. The right shift operator with sign extension shifts all the bits of the binary number to the right by the number of positions specified by the second operand. The bits shown in red are the original bits, and as they shift right, the rightmost bit is discarded and it can never be recovered. The vacant positions on the left created as a result of this shifting are filled with the original most significant bit, also known as the sign bit of the number. In this case, as you can see over here, the sign bit was 1, so the positions are getting filled with the value of 1. Right shift effectively means to divide an integer by 2. Next is the assignment operator, represented by the equal sign. It is simple. It assigns the value on the right hand side of the variable to the left hand side. Assignment can also be combined with arithmetic, bitwise, and shift operators for more concise expression. They are known as compound assignment statements, and an example of that is shown over here. Lastly, we have the unary increment and decrement operators, which operate on a single operand. The increment operator increases a variable's value by 1, while the decrement operator decreases it by 1. These operators comes in two forms, pre and post. Both pre and post versions ultimately adjust the variable value, that is either increase or decrease by 1, but they both differ in the value which they return. The pre-increment operator returns the updated value of x. In this particular example over here, it will return a 2, while the post increment returns the original or older value of x. In this example, it will return a 1. The same rules apply to pre and post decrement operators as well. That was an elaborate discussion on operators. But now, with everything covered, you will never need to consult another resource on this topic. We have got you fully equipped. We covered a lot of fundamental ground in this episode. Here's a quick recap for you. Java follows the Unicode character set that must be obeyed while writing your program. It comes along with 8 primitive data types to store different size and kinds of data, like int, byte, short, and long for integers, float and double for floating point numbers, char for characters, and boolean for logical values. Literals are constant, and by default, they have a fixed data type attached to them. However, that can be overridden by suffixing the literal with capital F for float, capital D for double, and L for long. Identifiers are names that are used to distinguish various entities in a program. Variables are data warehouses. We need to attach a data type to a variable to specify what kind and type of data it can store. A named constant is a special variable whose value can never be changed throughout the program. Keywords are special words that have specific purpose and meaning in a Java program. To perform various operations on Java, Java provides a lot of operators like arithmetic, logical, relational, and so on that we just saw. And that's it for this episode. In the next episode, we will talk about different types of statements in Java programming language and how can you control the flow of your Java program using selections and loops. So we are done with the first 2 steps in learning the Java programming language. That is the character set of Java and the words in Java. So thanks again for watching. If you enjoyed the animations and content, please consider giving this episode a like. It really helps the channel grow. And if you want to see more content like this, don't forget to hit the subscribe button and ring the bell notification so that you never miss out on an update.